Through the years, Ontario Power Generation has been committed to upgrading and maintaining its hydroelectric plants to produce more clean, renewable electricity for the people of Ontario. Ontario is a land rich with water. 4 of the Great Lakes and the St. Lawrence River line its southern border. To the north lie Hudson's Bay, James Bay, and the powerful Ottawa River. In between is a vast area of countless lakes, rivers, and waterfalls. For over a century, Ontario Power Generation and its predecessors have invested in the power of water to help fuel the growth of the province. In 1906, the Hydroelectric Commission of Ontario was established, with visionary Sir Adam Beck at the helm. An epic construction project rose on the Niagara River. And in 1922, the world's largest hydroelectric generating station dramatically launched the era of hydropower in Ontario. Over the following decades, an impressive fleet of hydroelectric stations of all sizes were built throughout the province to supply the electricity needs of a growing population. Producing clean, renewable electricity from the power of water is Ontario Power Generation's heritage. The company is focused on maintaining and improving these treasured assets for the people of Ontario. Today, Ontario Power Generation operates more than 60 hydroelectric stations and over 200 generating units on 26 different river systems. They also operate over 230 dams to control the flow of water to those stations. At each station, sophisticated automation controlled by Ontario Power Generation's 5 regional centers manages the entire system for maximum safety and efficiency. Ontario Power Generation closely monitors the flow of water. Official watershed management plans are carefully followed that balance the need for electricity with the environmental, commercial, and recreational needs of all the users in the watershed.
Hydroelectric production is very important to Ontario Power Generation. It accounts for about 30% of the power that we produce and in fact represents about a quarter of the power consumed in this province.
Hydroelectric stations all use similar processes and equipment to generate electricity. Water collected above the station is channeled downhill through large tubes towards a type of water wheel known as a runner. The water passing by the runner spins it, which in turn rotates a generator that creates electricity. By the 1970s, some of Ontario's hydroelectric stations had been faithfully generating power from water for half a century. Unfortunately, the original turbine runners were vulnerable to a unique phenomenon called cavitation, when water vapor bubbles created inside the turbine collapse and create shock waves.
If that happens, it will create pits and eventually holes in the turbine blades, and then the runner either has to be repaired or replaced.
Engineers began to explore the options available to maintain the aging hydro turbines into the future. They concluded that modern runner design technology could reduce costly maintenance and offered the added potential to produce more power from the existing plants. The turbine upgrade program was born.
The turbine upgrade program is taking the hydroelectric fleet across the province and improving the efficiency of the equipment so that we can get more power from the existing unit.
Primarily, we replaced the turbine runner, but we also replaced other components within the water passage to improve the efficiency of the use of that water in the late 70s and early 80s. The biggest challenge was convincing people that these benefits were for real.
Changing a runner was not common practice at all. OPG, Ontario Hydro at the time, was a pioneer, and people looked to us to see how it was done.
It takes a bit of faith in your design engineers to go out and take a perfectly good turbine runner and scrap it and put in a brand new one, which is a very expensive proposition, on kind of a technical say-so.
Other companies followed the same practice because they saw what a good idea it was. You could just change some components and get a lot more power and energy.
Hydro turbines use water as fuel, and modern runners are capable of using that water more efficiently than the original handcrafted equipment. Today's turbine engineers use computers to design the replacement components and run simulations to help them test their designs. Finely detailed scale models of the entire generating unit are then built and tested in hydraulic laboratories to further refine the concept. The result is a runner design that virtually eliminates cavitation while also generating more energy from the same amount of water. Transferring the ideal design from the computer to the real world is a long and technically challenging process. Some of Ontario Power Generation's runners are almost 7 meters in diameter and weigh tens of thousands of kilograms. Yet they must be precisely manufactured to incredible tolerances of less than the width of a human hair. Highly skilled craftsmen can take up to a year to build a runner, cutting, welding, and grinding the steel into shape. The technicians carefully wield giant computer-controlled machines to bore and mill the runners to the exact specifications the design demands. The runner blades are also crafted out of advanced stainless steel that resists cavitation, thereby minimizing maintenance costs and extending the life expectancy of the equipment.
They're designed for a 60 to 70-year life, but in actual fact, if we don't have cracking or cavitation damage, they could last for 100 years or more.
Long before the replacement runner is delivered to the station, highly skilled Ontario Power Generation maintenance trades are on site to overhaul other components in the unit and prepare it for the upgrade. Even though the stations are constructed with enormous volumes of concrete, there is minute settling and shifting over time that must be accounted for when aligning all the parts for installation of the new runner. A laser guidance system is used to line up the embedded parts to within a few thousandths of an inch to ensure that the turbine operates smoothly for decades. When everything is ready, maintenance crews carefully move the runner into position, and the new unit is bolted into place. The primary advantage of the turbine upgrade program is the additional energy that is generated from the same amount of water at the existing stations. From 1992 to 2006, 427 megawatts of additional capacity have been added to the hydro fleet, with over 125 megawatts in the last 5 years.
Since the beginning of this program, we have upgraded over 115 units across the province. The energy that this additional hydroelectric capacity gives us is enough to supply over 100,000 homes every year.
The other advantage is typically most upgraded units have a much higher reliability and a lower maintenance cost. And that's because the designs are better and the materials are better.
Through the turbine upgrade program, Ontario Power Generation is squeezing out every megawatt of hydroelectricity possible. Over the next 5 years, another 53 megawatts are scheduled to be added. By 2012, the turbine runner upgrade program will have added enough clean, renewable hydroelectric power to avoid over 900,000 tons of global warming carbon dioxide every year.
Hydroelectric is a clean, reliable, dependable source of energy. It simply makes sense for us to continue investment in these assets. The turbine upgrade program is a good example of that. It allows us to make sure that the water that Mother Nature gives us, we can make the maximum, most efficient use of in our plants.
And I think all of us are very proud of what we've been able to contribute, and to know that our contributions will continue to produce clean, reliable power.